Okay, this is 3.4 of geometry. We've got quite a few theorems here. So this first theorem says that if A is parallel to B, so if these two are parallel, and if B is parallel to C, then A is parallel to C. Alrighty, our next theorem says that if M is perpendicular to T, perpendicular, remember, means that they're making a 90-degree angle, and N is perpendicular to T, then M and N are parallel. This proof is a pretty short one. So if I look at my picture here, I'm given that R is perpendicular to T and S is perpendicular to T. And I'm trying to prove that they're parallel. Well, if I look at this angle and this angle, or they're looking on the other side, right? If this guy is 90, then this guy is also 90 because they add up to 180. And same thing, if this guy is 90, then this guy is also 90. So I know that angle 1 and angle 2 are right angles. So angle 1 is congruent to angle 2, and they're corresponding angles. And since corresponding angles are congruent, then the lines are parallel by the converse of corresponding angle theorem. Okay, a carpenter plans to install molding on the sides and the top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angle as shown. Will the side pieces of molding be parallel? So we want to know, will these two guys be parallel when we put it together? And if you picture squishing these guys together so they make a corner, I have that's pretty bad. 45 and 45 degrees coming together, which means this whole thing is 90. And same on this side, this will also be 90. 90 degrees means that they are perpendicular. So I have two lines, these two guys are perpendicular to this one. And we have a theorem that says if two lines are perpendicular to the same line, then they are parallel. Okay, if I look down at my picture down here, it says, can you assemble the pieces at right to form a picture frame with opposite sides parallel? So, if I take my pieces with 60-degree angles and then stick the pieces with 30-degree angles on them, that's going to turn out to be 90 and 90, so right angles. Again, if they're perpendicular to the same line, then these two guys, this one and this one, are parallel. So yes, I assemble it like this. Another theorem. Okay, if N is perpendicular to L, this bit there, and L and M are parallel, then N is perpendicular to M. So right here, that is perpendicular. Forms a right angle. Okay, we're just going to skip down to our got it problem. Can we conclude that A is parallel to B? If I look right here, D is perpendicular to A, and D is perpendicular to B. So yes, A is parallel to B. And there's your homework.